Hello YouTube and welcome to What the Math. In today's video we're going to be building an SSTO to Duna. Basically a single stage to orbit to Duna, and it's something I've already achieved before, but I wanted to do it from scratch using some of the things I've learned from the previous attempts and previous failures. Alright, let's get on with it. And let me start by showing you some of the previous designs that I tried to land on Duna that kind of work, but not really. So this right here actually works really well. So there's a bunch of ion engines in the back, there's a jet engine in the back as well, and this allows me to basically take this off Kerbin easily and then guide it to Duna. But the problem is I wasn't able to land this because it's a plane design. And because Duna is full of mountains, really treacherous mountains, I wasn't actually able to land this on the planet. So I had to change my designs a little bit. One of the designs called for parachutes that would actually open up and try to land this vertically, and then I would use ion engines to take off from Duna. But there's a few more designs I tried that didn't really work as well. For example, here's the one where I really tried to use both the plane design and the parachutes, and I've actually used a similar design to land on Lathy quite successfully, but on Duna it just doesn't work. So there's a parachute right here, and then it's supposed to basically use these strut leggy thingies, whatever they're called. What are they called? Landing struts, there you go. Strut leggy thingies. Landing struts to land vertically and then take off using ion engines. And it can actually do it easily because it does have enough propulsion, I believe. Let me just double check. Duna. Okay, maybe not. Actually, it does when it's empty on fuel. So it does have like over 1 TWR to take off Duna. But unfortunately, that still didn't work really well. I had trouble landing. It was going too fast on the landing approach and almost always destroyed itself. So I had to try something completely different. And by completely different, I mean I decided to make a rocket instead, a single stage to orbit rocket. I'm gonna show you what I've made, and this is actually relatively successful, but it's not super successful, and I'll explain why. So basically the way this works is there is a seat for a pilot on top, there's ion engines on the sides, along with the solar panels. There is a repair engine on the bottom, and this is supposed to take you all the way to the orbit, and then you would switch to ion engines and finish your orbiting maneuvers using ion engines. This, however, you keep basically the fuel that you have inside here, liquid fuel and the oxidators, you keep until Duna, and then basically use this to take off from Duna. Now it sounds really awesome on paper, and it does have, let me show you, it does have all the necessary TWRs and everything else for it to actually take off Duna. So if I decrease the liquid fuel, you'll see that. Yeah, okay. It does have quite a lot to take off Duna. Now, the problem is that I was not able to take this to orbit from Kerbin. I actually struggled with this a few times, mostly because I don't think I put enough ion engines. And putting more ion engines means that you can't actually take off this from Kerbin, because as you can see, if I add more weight to this, the TWR decreases dramatically, and then it's not actually as efficient at taking off from Kerbin. So once again, back to the blackboard, design board, whatever it's called, to try to recreate a new design using similar features. And finally, I've succeeded, and you're about to meet the beast that actually was able to land on Duna. And this is a design I call Duna SSTO Mark 4. I guess you could call it SSTD. Okay, that doesn't actually sound really good. SSTD is supposed to be single stage to Duna, but sounds really bad. So that's it. This is it. Let me just remove this for a second, and I'll explain this to you, how this works and why this works really well. So I've decided to add a command pod Mark 1 because it sounds more realistic, even though it added extra weight, but you can actually remove this and just put a seat here instead. There's a parachute on top, and there's another 4 parachutes, and that's 4 big parachutes, very large Mark 16 XL parachutes on the side. Now these are super important because Duna doesn't have much atmosphere, and chances are you'll be landing at a high altitude, meaning that this will save your life, or try to save your life. If you don't bring enough parachutes on Duna, and you need actually more than Kerbin, if you don't bring enough parachutes, you will most likely crash no matter what landing struts you have. I've also added huge amounts of air intakes because I'm totally going to be air hogging all the way up to Kerbal orbit. These actually, as I've later realized, are not very useful. These panels were supposed to be extra energy providers for my ion engines, and there's actually 8 ion engines now. 1, 2, 3, 4, 5, 6, 7, 8. So that's basically double of previous attempts. And these ion engines are powered by 2 solar panels here, and then 2 more here. Although in retrospect, I should have really just put 2 here and 2 here, because usually the sun will be from my back, and that provides a maximum amount of energy. I also should have put a few more solar panels on the back here, but that's okay. I'm not gonna do it now. And the important part is this: how do you get to orbit from Kerbin? Well, it's using these 4 Rapier engines. These Rapier engines will first air hog to an altitude of about 30 kilometers and hopefully speed of about 1700 meters per second, and the last part will be using the closed stage. So this is air breathing stage, and then it's going to switch to a closed stage where basically you're going to take this to almost complete orbit around Kerbin. Ion engines will then kind of, you know, circularize everything and finish your orbit. I do have enough fuel for in my ion engines for quite a lot of maneuvering. That's why I've actually added 3 drums instead of just 1. And the last part is this. This is the important part. This beauty right here, this nuclear engine is essentially how you're going to be taking off from Duna when you land. Now, it may not sound really powerful, but on Duna, let me just show you. On Duna, it is quite powerful. This is stage number 1. Yeah, stage number 1. If I decrease my fuel here, if I actually remove my fuel, you'll see that it's already at higher TWR than 1, meaning that it can actually take off from Duna. On top of that, I'll be using my ion engines to give it some extra boost. Now, I don't need that much oxidizers, as I've later realized, so I'm going to decrease this a little bit more, because it's extra weight for me later on. Okay, so let's actually see if I have all my action groups selected correctly. For my number 1 button is going to be opening my solar panels. Number 2 button is switching my Rapier engine, and then number 3 button is to turn on my ion engines. Alright, perfect, that's all I needed. So let me show you how this thing flies. It actually flies really well. Oh, and by the way, these landing struts are, they're not particularly powerful on Kerbin. They do bend a lot, but on Duna they work really, really well. You just have to be careful where you land, because if the suspension goes in too much, it may actually take out your nuclear engine. And make sure that if you are building something similar to this, that you take off during preferably sunrise, but I think I'm in an afternoon right now, so I'm gonna try to take off during the afternoon as well. Alright, so start my engines, turn on my SAS, wait for my for the thingy to get to at least 1, and release the thingamajig. There we go. I can actually redeploy my gear as well. I mean, retrieve my gear. So it does fly pretty well. And I'm gonna skip this part, but basically what you're doing now is you're going to approximately 10-11 kilometers, starting to turn eastwards slowly, and at around 20 kilometers going almost horizontally, just to basically increase your speed horizontally as much as possible, even if you're going against air drag. So you'll see that, and I'll show you this when I get to higher altitude, where my atmospheric efficiency, which basically represents how efficient your engines are at particular speeds, or basically if this is 100%, this means that you're not wasting any fuel when flying in the atmosphere. If this is more than 100%, it means that you're losing some of the fuel due to air friction. If it's less than 100% like it is right now, I'm losing some fuel due to gravity. So it has to be close to 100%, but you will be going at about 130%, because here it will be important to basically get as much horizontal speed as possible. Alright, so at around 12 kilometers, I'm going to start realigning myself horizontally, and by about 20 kilometers, I'll be going almost completely horizontally, increasing my surface speed to as much as possible. Now, this will take me a while. It usually takes about 20 minutes to get to orbit this way. But basically, the idea here is that you're air hogging, which means that you're using the maximum amount, or as many radial intakes or any other air intakes, to use the air to as high altitude as possible. Now, if you didn't actually know this before, but the way this works is the higher proportion of air intakes you have compared to the rest of the mass of your ship, the higher altitude you can use these things at. So basically, if I put a little bit more of these, I can actually use them at a higher altitude, which means that I can use air hogging even higher. But oh yeah, I forgot to mention I did disable automatic switching. So these repair engines that can only be switched manually, which means that I have to use this a little bit more carefully. Otherwise, my ship will start spinning out of control. But here's the important part: if this ship were lighter, so if I actually just have one engine and basically one fuel tank, and I put as many air intakes on it as I have right now, it means that I can actually use the air breathing feature of my jet engine at a much higher altitude, because it goes by proportions of weight. So the proportion of air intakes to everything else will determine how high you can use your jet engine. All right, so we started burning up because currently we're at 140% efficiency, atmospheric efficiency. That's not really important to us because we're just basically trying to get as much lateral speed as possible and without getting too high, because we're basically trying to use as much air as possible, as much air engine as possible before we switch to the closed circuit engines. Alright, so I'm still trying to air hog a little bit more, even though my ship is kind of spinning too much. Alright, I can actually switch to the closed circuit engines now and basically blast them at 45 degrees away from the surface, so that I can basically reach my orbital node, orbital apoapsis right here, and this should be at around 80 kilometers. And now, alright, so stop the engines now and then fly. Oh, and I still have quite a lot of fuel left. Now basically we're flying toward this apoapsis, and at this point we'll actually straighten our orbit a little bit more, and hopefully we'll have enough fuel to do that. 430 meters per second. Okay, we don't have enough, so that's why we're going to release our solar panels and start blasting our ion engines. And using the ion engines, I'm basically going to try to get as much speed as I can before finishing my orbital realignment with my repair engines. This will give me approximately 100 more meters per second. And let's finish up our fuel and try to circularize this orbit. I'm just basically going to use up the rest of my liquid fuel from these 4 engines. And hopefully this will leave me with nothing inside of them. Sometimes there's some extra oxidizer left in it. Sometimes there's something extra. Okay, so 21 oxidizers left, but that's okay. That's not too much. It will, however, cause me a bit of a problem when I'm trying to take off from Duna, because it will give me extra weight. Unfortunately, I don't have the mod that allows me to dump fuel, although I would definitely recommend using this, because you can then dump almost 80 liquid fuel or oxidizer, which you don't really need anymore. It's not really useful. Okay, so now I'm just going to use my ion engines to finish circularizing my orbit, and this will be the first stage of this journey. And once you get into orbit around Kerbin, you basically want to start planning your exit maneuver or escape maneuver. Usually the way it works is you want to position this at around, so if this is Kerbin right here, this is 6 o'clock, this is 12 o'clock, you want this to be at around 5 o'clock. And there's a specific point where you want to burn your engines. So if you're using ion engines, it's unfortunately going to take you quite a while. You want to start burning your engines right here and stop burning them right here. And this will take you actually 6 or 7 orbits around Kerbin. So first orbit, you're going to start burning here, finish here. It will increase your apoapsis a little bit. Then you can come back, burn them again. It's going to increase the apoapsis again. Do this a few more times until you basically reach the escape. Or until you have apoapsis that's really high, somewhere like right here, and then you can just basically finish burning your engines or increasing your speed at this particular point by doing this. And this will basically allow you to escape Kerbal gravitational field. And once you do this, you go to the main map and place the where is it? Where's the Duna? There it is. Place the target marker on Duna and start playing around with your nodes until you get an intercept. Usually you need about 1200 or maybe 1100 meters per second to intercept Duna, so it's not too much. I currently have okay, I don't have that much, but I currently have about 4, maybe 3,500 meters per second in my ion engines, and then I have about 1700 more in my nuclear engine. So I'm going to go ahead and basically skip this part because this is the long and boring part where I'm going to try to escape Kerbal gravitational field using nothing but ion engines. It takes about 40 minutes to do that, so I'm just going to skip this part. And fast forward a couple of hours, and here we go. We're basically on approach to Duna. I'll show you some. So as you can see, this fuel tank is empty. This one here is empty. I have approximately 8,000 xenon fuel left, which allows me to blast my engines for, where is it? Okay, 1600 meters per second. And I still have quite a lot of fuel left in my nuclear tank, which allows me to blast my engines for 1700 meters per second. Now both of these I need to take off to basically, to launch from Duna. So I'll need as much of it as possible, and then the rest, approximately 1,000 or so, I'll need to land back on Kerbin. Now this is Duna. I'm gonna approach it really gently, really nicely, because this is actually the most difficult part of the process, the landing part. Now it actually it took me a few times to land because every single time I'm going too fast, things get out of control, and then this thingy does not land properly and explodes. And I'll probably show you this to you a few times because it will probably happen again. But let's see what we can do here. Before I actually go on and land on Duna, I'm gonna accelerate a little bit because I want to actually pass by Duna and just show it to you in case you've never seen it before. Alright, so once I increase this periapsis to 12 kilometers, this will give me an opportunity to pass by Duna, and this is actually a perfect opportunity to assume an orbit if you wanted to assume an orbit, or just, you know, fly around and watch its skies and its ground below you, because it's a pretty beautiful planet. It's actually quite majestic, and there's quite a lot of stuff to see on it. Alright, so here we go, 12 kilometers, and I'm just gonna accelerate time and wait for us to approach it a little bit closer than that. We're coming from the dark side, so that's not good because you won't be able to see much, but we will be flying through the through the bright side as well once we pass by it one time. So you can't really see anything here right now. It's too dark, but that's okay. Just wait a few seconds. Okay, here we are flying across its skies at 12 kilometers, and as you can see, I actually am not crashing into it because I don't think I'm going low enough, and the atmosphere of Duna is actually quite thin, so it doesn't really slow you down that much. But look at this beauty. We actually get to witness sunrise and a bit of its really thin atmosphere as well. I'm not sure why my ship is so white though. What's happening here? Something's shining. So anyway, so this is basically Duna. Welcome to Duna, and now let's try to land on this planet. This is honestly one of the most difficult planets to land on, at least in my opinion and in my experience, because every single time something goes wrong. This is a very mountainous planet. There's almost no flatlands here. There's actually, I haven't found a flatland on Duna. I don't know if you know something that I don't, but even the even the caps here, if you look at the caps, they're full of mountains. There's like not even a thing here. It's all full of mountains. Both sides, both caps are full of mountains. So yeah, there's really nothing you can do but try to rely on luck to try to land here. And this is what we'll be doing. We'll be relying on luck. Okay, so beautiful sunrise, and let's fly through the skies one more time. And oh, this is Ike, by the way, the satellite of Duna. Ooh, we might even witness what would that be? Ikeclipse? Ikeclipse. Yes, that's right. It's called Ikeclipse. Or maybe not. We might have missed it actually. So yeah, this is Duna, very beautiful planet. It does have, especially if you're using the atmospheric mod, it does have some really nice effects, such as dark black clouds and dust storms on Duna, which you'll see when we land, if we land, that is. Hopefully we'll land. But I also need to release my parachutes. I forgot to release my parachutes. The parachutes are super important if you want to land safely. Now, honestly, in terms of parachutes, I recommend bringing as many as you can. There is a calculator you can use online. If you Google Kerbal Space Program parachute calculator. You'll find it quite easily, and it will tell you how many parachutes to bring depending on your ship size and mass, or really mass, not the size. And here I needed to bring at least 5 if I want to land at a speed of about 13 meters per second. I'll also probably be using a bit of my engine here just to slow down even more. Oh, Eclipse is coming. Look at that. This is quite a good timing to arrive. And look at that. We've actually witnessing Eclipse, probably the first in Kerbal history. So beautiful Eclipse and complete darkness. Well, almost complete darkness. And yeah, so this is actually a really good timing to be landing. Now, as I'm decreasing my altitude, it's actually going to start slowing me down. And at some point, my parachutes will release and slow down my descent to about, I think, depending on altitude, it's about 12 to 16 meters per second, which is actually just enough to sort of crash on the planet. Now, you want to be going slower. You want to go at around 10 to 11 meters per second, so I'm going to be using this engine to try to slow myself down as much as possible. Interestingly, even though there's an Eclipse going on, I should probably stop calling it that, but even though it's going on above us, this planet is still quite bright. Alright, so the sun is back, or Kerbal is back, and it's about time we've landed on this planet.